Smart contracts, they're really the engine behind so much on the blockchain, aren't they? Code acting as law.
Absolutely. But actually writing them securely, efficiently, that's often been the tricky part.
Exactly. But what if there was a language designed, specifically to tackle those challenges?
Well, that's what we're digging into today. We're taking a close look at Aiken. It's really starting to make waves as a go-to language for smart contracts, especially thinking about Cardano in, say, 2025.
Right. And for you listening, we want to make this really clear. What is Aiken? Why is it being seen as maybe the option for Cardano development soon? How does it compare? And importantly, how could you start using it?
And to do that, we've pulled together quite a bit, blog posts, some technical docs, materials from developer programs. It gives us a few different perspectives on how Cardano's whole smart contract world is shaping up.
Okay, great. So let's get straight to it. Aiken, what's the core idea?
At its heart, Aiken is what we call a purely functional language. It's also got static typing and type inference.
Okay, purely functional. What does that mean in practice for a smart contract?
It essentially means functions are predictable. You put something in, you get the same thing out every single time. No hidden side effects changing things unexpectedly. And, on a blockchain dealing with value, that predictability is gold.
Predictability, yeah, that sounds crucial. And statically typed and type inference. Break those down a bit.
Sure, statically typed just means the language checks all your data types, like numbers, text, whatever, before the code runs. It catches a ton of potential bugs really early on.
Ah, so it finds problems sooner rather than later.
Exactly. And type inference is a nice helper feature. The compiler can often figure out the data types itself, so you don't always have to write them out explicitly. Makes the code a bit cleaner, maybe easier to write.
So the design philosophy seems to be about safety and, well, clarity.
That's the gist of it. And it's a very deliberate choice to keep it simple for these on-chain scripts. Aiken intentionally leaves out some super complex features you might find in other big functional languages, things like higher-kinded types or type classes.
Why leave those out?
The thinking is, for most Cardano smart contracts, those advanced features add complexity, maybe even new ways things could go wrong, without actually being needed for the job. Keep it focused.
Makes sense. Focus on the essentials for the blockchain context. So if someone's listening and thinks, okay, I want to try this, what's the first step? Like practically?
The docs point to a pretty simple command. Aiken new, Aiken lang hello world. You run that in your terminal.
And that sets up a project.
Yep. It creates a couple of folders for you to live for your main code and validators, which is specifically for the smart contract logic itself. And it also creates a file called aiken.toml.
Aiken.toml.configuration file.
Exactly. It holds info about your project, dependencies, and importantly, it automatically includes Aiken standard library. So you get a bunch of useful built-in functions ready to go.
Got it. So the foundation is this focused, safe, functional language. How does that actually look when you build a contract? Can we walk through a simple example?
Absolutely. The materials give a good basic one. Let's say you want to lock up some assets, right? And you want only the owner to be able to unlock them, maybe by providing a secret password or phrase too.
Okay, like a digital safe needing the owner's key and a code.
Pretty much. This basic Aiken validator checks two things. First, does the transaction include proof of the owner specifically, their verification key hash inside something called the datum?
Datum. That's like the contract's settings stored on the chain.
You got it. It's the configuration data attached to the locked funds. And second, does the transaction trying to spend those funds include a specific message like hello world in what's called the redeemer?
Datum and redeemer, those are key Cardano terms, right? Part of the UTXO model.
Spot on. In Cardano's extended UTXO model, the datum holds the state or rules for a specific locked output. The redeemer is the input you provide when you try to spend it. It's what triggers the validator script to check if you're allowed.
So in this example, the datum says this is the owner, and the redeemer has to say hello world to unlock it.
Exactly. The Aiken code itself is basically a function. It takes the datum, the redeemer, and some transaction context, checks if the owner's key hash matches and if the message is correct, and then just returns true or false, valid or invalid transaction.
Simple, but it clearly shows how you enforce rules. It's like making sure only the owner's signature can move funds just with code.
Precisely. It mirrors that basic security of a regular address, but lets you add custom logic.
That really helps visualize it. Now, you mentioned Cardano has other languages too. Haskell was the original big one.
Yeah, Haskell via Plutus Tx was the starting point, and it's still very powerful. But the landscape has definitely grown.
So what are some of the other players?
Well, there's Helios. It's also functional, but it uses a syntax with curly braces, which might feel more familiar if you're coming from, say, C, Go, or Rust.
Ah, trying to lower the barrier for developers from those backgrounds.
Seems like it. Helios also lets you define things like structs and enums, even attach methods to them. Borrowing some ideas may be closer to object-oriented styles, though it's still fundamentally functional.
Interesting. Any other features of Helios?
They mention associated functions, kind of like static methods like from data or new for creating lists. And they seem to push platform flexibility, offering ways to integrate the library using simple WebScript tags or CDNs.
Okay, so Helios offers a different syntactic flavor. What else is out there besides Plutus Tx and Helios?
There are others popping up too. You've got OpShin, which aims to bring Python's friendlier syntax into the mix using a special Plutus data class.
Python, okay, that's popular.
And then there's Plu-ts, which is based on TypeScript. Again, the goal seems to be making it easier for web developers, who are often familiar with TypeScript, to jump into Cardano development.
Right, so a real variety of approaches now. Given all these choices, where does Aiken really fit? What's its unique selling point?
Aiken seems to be doubling down on that laser focus. Simplicity for on-chain validators. Haskell is super powerful, yes, but maybe more complex than needed for many typical contracts. Aiken is designed specifically for the constraints and common patterns of on-chain logic.
So the argument is that the full power of something like Haskell might be overkill, potentially adding complexity or cost for a lot of smart contract tasks.
That seems to be the core idea. Aiken aims to give you exactly the tools you need for secure, efficient validators without extra baggage that might not be relevant on-chain.
Okay, that makes sense. So looking ahead to 2025, why is Aiken emerging as such a strong contender? What's giving it momentum?
Well, it comes back to those core design choices we talked about. Purely functional, statically typed these things really do contribute to writing safer code, which is paramount.
Less room for error, basically.
Hopefully, yes.
Yeah.
And its focus on just what's needed for on-chain scripts could mean more efficient execution, potentially lower costs on the blockchain itself.
Yeah.
It's optimized for that specific environment.
Right. Efficiency matters on-chain. Is it just the language, or is there more to it?
It's definitely not just the language. The tooling around it is getting serious attention too. Aiken integrates with tools like gastronomy.
Gastronomy, what does that do?
It's essentially for testing and debugging your Aiken contracts. Really robust testing before you deploy anything with real value attached.
Which is absolutely critical in this space. What kind of tools does Gastronomy offer?
It gives you options. There's a command line tool, Gastronomy Client, if you like working in the terminal, but there's also a graphical interface, just called Gastronomy, for a more visual approach.
Nice. Catering to different workflows, how do you set it up?
Configuration seems straightforward. Things like your API key for BlockFrost, which lets you interact with the Cardano network, can be set using environment variables or a specific config file, .gastronomyrc.toml.
So, a solid testing framework. How does Aiken's design philosophy connect with Cardano's unique way of handling transaction fees?
That's a really interesting point. Cardano has this deterministic cost model.
Meaning, you know the cost up front, unlike Ethereum's gas.
Exactly. You can calculate the execution fee and the collateral needed pretty accurately before you submit the transaction. Aiken's focus on simplicity and predictability fits perfectly with this. By avoiding super complex language features, it likely makes it easier for the Cardano system to accurately figure out the cost of running an Aiken script.
That predictability is huge, I imagine, for developers' budgeting costs and for users understanding fees. Okay, so someone's convinced they want to learn Aiken. What are those first steps again?
First thing is installing the Aiken tools. Then run that Aiken new command we mentioned to get your basic project structure.
Right, the one that sets up lib validators and aiken.tom.
Yeah. And remember that aiken.toml automatically includes the standard library, so you have functions available right away.
Yeah.
The Hello World example we discussed earlier is actually presented as a first steps guide in their documentation. It's a good starting point.
Okay, install Aiken new, follow Hello World.
Yeah.
What about actually using these contracts on a test network?
The documentation highlights integration with Mesh. Mesh is a JavaScript library that helps your web application talk to Cardano wallets and contracts.
So Mesh helps bridge the gap between the contract and a user interface.
Exactly. Especially useful for testing on networks like the Preview testnet, often using BlockFrost as the connection point to the blockchain data.
And you need test funds for that?
Mm-hmm. They point towards using the Cardano faucet to get free test ADA, and also using blockchain explorers like CardanoScan to actually see your deployed contracts and transactions on the network.
Sounds like a pretty complete setup for learning and experimenting. Now, thinking about developers coming from other languages, we talked about Helios having a C-like syntax. If someone knows other functional languages, would Aiken feel familiar?
It's likely. If you're comfortable with functional concepts and mutability, pure functions, then Aiken's core ideas should resonate. While the syntax is its own, the underlying paradigm is shared with languages like Haskell or FTab, or even elements of functional styles in Scala or Rust.
So experience with functional thinking is a plus.
Definitely. The sources don't give a direct A to B syntax comparison with, say, Rust or Go beyond the Helios inspiration, but the principles of functional programming are key. Aiken is purely functional, remember, which is a strong design choice.
Understood. So let's wrap this up. Looking towards 2025, what are the main takeaways from our deep dive into Aiken for Cardano?
I think the main thing is that Aiken is emerging as a really strong, purpose-built option. It prioritizes simplicity and safety through its functional nature and static typing, aiming for efficiency, specifically for on-chain logic on Cardano.
It's carving out a niche by not trying to be a general-purpose language, but focusing intensely on the smart contract use case.
Exactly. And it's backed by increasingly sophisticated tooling like gastronomy for testing, and it aligns really well with Cardano's deterministic fee model.
Seems like a compelling package.
Yeah, all these factors together suggest it's well positioned to be if not the leading choice for many Cardano developers in the near future.
Okay, so a final thought for you, our listener, to chew on. As we see these specialized languages like Aiken gain traction, how might this shift the entire landscape of blockchain development? Especially in ecosystems like Cardano that pride themselves on, let's say, rigorous engineering. Could this move towards purpose-built tools be the future, rather than trying to adapt general languages for everything? Something to think about as you watch Aiken and the space evolve.